one, if you have forgotten the recursive ones, the first thing we need is how many dots there are at the beginning. All right, we need the starting point. And then after that, we need to know what the pattern is. So to get any other one, what do we have to do to the one right before it? Okay, so as you guys are looking at these dots, okay, count them up. I'm going to write on top of the dots like how many there are. Okay, and let's help me if you guys can. If anyone sees the pattern, just let me know. If you've seen it already, just say, go ahead, say it.
Isn't it multiplying by 2?
Good. Starts with 3, and then we multiply by 2. So that means the 3 is what goes in there. That's like what we start with. And then the pattern at the end is just times 2. And so that right there, that's the recursive formula for that pattern of dots. All the multiple choice answers. So we had to come up with this one from scratch. But if you can come up with something from scratch, then you're definitely going to be able to pick it in multiple choice. Okay, so I'm trying to make it harder here, so that way when you get to the test, it seems easier. All right, let's see in the chat. Okay, so we're going to go on to the next one now, and I already said, see, I already did one for you. I told you guys I wasn't going to do them all, I was just going to start them, just because I want you guys to be able to practice. Okay, but I kind of also want to give you examples. Okay, so now it's saying, same pattern, okay, but it wants to know what the explicit function is now. So not the recursive, but the explicit. Okay, so let's see here. So let's scroll down. Oh wait, we're here. Okay. So now if you guys remember the explicit ones, they don't need the starting point. We just need the first amount of dots, and then we need the pattern. Okay, let me go back to that. Okay, so here we have 3 dots to start with, and the pattern, every time we move over, you guys told me we're multiplying by 2. Okay, so these are all numbers that we've already figured out. So this is how you would write this pattern. It's always the first number we have, so we start with 3 dots, and then we multiply it by 2 that many times. Okay, so that would be the explicit function for that one. All right, and again, there's other videos of this on YouTube. Okay, so that's number 2. When we get to number 3, it says, now what type of sequence fits with the dot pattern below? Okay, so sequences, I kind of messed up. I didn't really teach you this. I kind of taught it to you last time, if you remember these. I'm just going to write this up here. I'm going to remind you of this. Okay, and again, this is in the video. An arithmetic sequence is the same thing as linear. Okay, we talked about that. And then we said that the other one called geometric, a geometric sequence was the other one. That was the exponential. Okay, so if arithmetic is linear, and remember, I don't know if, well, who remembers what linear is? What's the pattern like with linear? Good. Okay, adding or subtracting, good. All right, so linear is adding or subtracting. Okay, that means arithmetic is adding or subtracting. Okay, they're like the same thing. So then that means that exponential must be multiplying or dividing. Okay, so multiplying or dividing is the geometric one. Okay, so now let me ask you guys, who do you think, if you think you know it, go ahead. What type of sequence do you think this is? Is it arithmetic or is it geometric? I'll put it back up there. Remember, arithmetic is adding and subtracting. Geometric is multiplying or dividing. So what are we doing here? What was our pattern with these dots? Okay, so good. This is good. We got people saying both things. Okay, so let's start with what Emmanuel said here. The pattern is times 2. Good. Good, Jasmine. The pattern is times, remember, and geometric is multiplying, timesing, or dividing. Okay, so just remember, multiplying is geometric. Okay, multiplying is geometric. Here, adding is arithmetic. Think about the two A's. Adding is an A. Arithmetic is an A. Alright, so adding goes with arithmetic. Multiplying goes with geometric. Okay, so this is something here that we've done a bunch of times. Okay, so you guys have to figure out the pattern. It goes from 4 to 9 to 14. Remember, we only have two options. It's either adding or subtracting, or it's going to be multiplying and dividing. Okay, so it's either this, or it's nothing. Alright, so it's your guys' job to kind of figure out that pattern. Alright, as we go down here to number 5, now I tell you, if the sequence below is geometric, then what will the next two numbers be? Okay, so again, I'm going to remind you because we kind of just talked about this. Geometric is multiply or divide. Okay, so if I'm telling you this is geometric, then that means to get from 6 to 8, what did we multiply or divide by? Okay, and so once you figure that out, you just got to do it 2 more times. Alright, number 6 says if the sequence below is arithmetic. Okay, remember, arithmetic, adding or subtracting. Okay, so now it's like, okay, go from 6 to 18. What did we have to add or subtract to do that? Alright, and it's your guys' job to figure out what that is and then continue the pattern. Alright, let's see here. Okay, 7. Okay, 7 says to create a table of values that fit with the recursive rule. Okay, so I don't know if you guys remember the time where I told you we had to make, if I give you this list, you have to make the first 5 numbers of it. Okay, so if this was your recursive equation now, somebody tell me out loud, what would be the first number of our list? Okay, so I got a list here. We don't know what it is. We're trying to use this equation to figure it out. Okay, I'm going to check the chat right now. But we're trying to figure out, again, just what's the first number in that list. Good, Brian. Oh, good, Adrian. I saw that in there too right now. I didn't see it before, sorry. Good with the times 3. Okay, so Brian, good. You saying start at 1. What do we have here? And then Emmanuel's saying, okay, Emmanuel's saying add by 3. So I'm going to go back to this now. Okay, good. This is telling me over here to start with 1. Okay, so that means my first number in this list is going to be a 1. Then the pattern tells me after I start with 1, whoops, then I have to add 3 after that to get the next numbers. Okay, so then 1 plus 3, 4 plus 3, 7 plus 3, 10 plus 3. Okay, so these are your first 5 numbers of the list. Okay, now let me show you how you would put those numbers into a table. Remember, the numbers in the list, those are the Y's. So those are going to be the ones that go on the right side. Those are the outputs. And then the ones on the left are kind of easy. They always go by 1s. This was the first number of our list. This was the second. This was the third. This was the fourth. This was the fifth. Okay, so that's kind of how... Okay, you can tell me what kind of a function this is right here. There's an x in the exponent. So is that linear or exponential? Who remembers? Good. Exponential. So there's... Good, Maya. Good, everybody. There's a couple ways to know now. I said one of them, the x in the exponent, but there's actually another way. Can anybody think, like, judging by, just look at the equation, what else in this equation would tell us that it's exponential besides the exponent? What's the key thing? Excellent. The multiplying. We're multiplying every time. That's what that tells us. So we know that has to be exponential or geometric. Okay, so if we wanted a table of values for this one now, okay, remember first number, second number, third number, fourth number. All right, now kind of going backwards here, looking at this equation, what's the first number of our list going to be? Is it the 4 or the 3? Excellent. So now we're kind of like using what we know about the formulas to go backwards. Like, so if I give you the formula, you know that that first number has to be the first number of the list also. So we know this is going to be 4. And then you guys told me the pattern is the multiplying by 3 every time. The pattern's also always the one that has the exponent on it. If that makes sense, the pattern is always going to be the one with the exponent. Okay, so then it's going to be 4, and then multiply by 3, then multiply by 3, then multiply by 3. I think I did that right. Okay, we're not going to go over this one. Here's a table. You have to just tell me, is it arithmetic, meaning linear, meaning does it add or subtract every time? Okay, we know a couple things about linears and arithmetics now. Or is it geometric, which means exponential, or it also means multiply or divide? That's a question mark. Whoa. All right, so again, we're just trying to figure out, based off these numbers here in the pattern, our numbers of our list for 11, 18, 25. Okay, which one of these are we doing? Are we doing this? Or are we doing that? Okay, so it's really kind of the same questions that I've been asking you this whole time. Like, I kind of stopped labeling the notes like 1.1, 1.2, because all we're really doing is talking about linear and exponential. Okay? And arithmetic and geometric are the same exact things. All right? So here we have another table. Determine if it's arithmetic or geometric. So is it adding, subtracting? Is it multiplying, dividing? That's kind of cheap. Kind I kind of gave you guys a little hint right there. You should recognize that table. All right, so we kind of should already know what's going on there. Same thing here. Adding, subtracting, multiplying, dividing. And that's it.